Now we're going to consider an example where we're given a situation, a real-life situation. Here's an example of a random variable that follows a normal distribution. SAT scores are approximated well using a normal distribution, also known as a normal model. The distribution of SAT scores follows a normal distribution with a mean score equal to 1,100 and a standard deviation score equal to 200. With the mean and the standard deviation, the normal distribution curve here below was created. Notice that we have the mean at the center of the distribution. We can use the standard deviation to label the first standard deviation to the left and right, the second standard deviation to the left and right, and the third standard deviation to the left and right. We can continue to label more standard deviations, but usually when we go ahead and sketch the graph, we go ahead and stop at 3 standard deviations. With this normal distribution curve, we're going to be finding probabilities. I'm going to be showing you how to find these probabilities using a calculator and using Google Sheets. Let's start with part A. What is the probability that a person scores less than 1,190 on their SATs? First, let's visualize the area we're trying to. First, we're going to write this probability using probability notation. We can go ahead and write the probability of X being less than 1,190. Here, we're going to assume that X is the SAT score for an individual. So that is the probability we're trying to find. Now, let's go ahead and visualize the area we're trying to find. For part A, B, and C, I'm going to be using the same curve. I'm going to be drawing on it, and then I'm going to be erasing. I would recommend drawing a small curve here below each part. Okay, I'm just going to be using this image here above, just because it's a little bit bigger and you can see it better on your screen. We're trying to visualize this area. We are finding the area below 1,190. 1,190 is around here. We don't have to be exact. This is just an approximation. This is just so that we can visualize the area. We are finding the area below this X value. If you're using a calculator, you're going to use the normal CDF function. The normal CDF function is going to ask you for the lower bound, the upper bound, the mean, and the standard deviation. In this case, your lower bound is going to be a really large negative value, that is -1E99. Again, we're saying find the area between -1E99 all the way to X equal to 1,190. And again, you're going to be asked for the mean, and you're going to be asked for the standard deviation. So that is how you find this area with the calculator. Now with Google Sheets. Now, if you're using Google Sheets or Excel, on an empty cell, you're going to type in equal norm.dist. Notice you're finding the area below a given X value. This function is going to give us the area below the X value we enter here. Here we're going to enter our X value, which is 1,190. Then we need to provide the mean, then the standard deviation, and then we go ahead and type in true. That is how you find the area to the left. Go ahead and use your calculator or Google Sheets or Excel to find this area. I'm going to write the area here. I'm going to round to 4 decimal places. You should be getting 0.6736. Please make sure to try it from your end. Go ahead and use a calculator. Go ahead and use Google Sheets or Excel. Make sure that you're trying this on your own. Make sure that you're getting familiar with your calculator or with Google Sheets. Now, let's find the probability that a person scores a 925 or better on their SATs. First, we're going to write this probability using probability notation. Here we have the probability of X being greater or equal to 925. You might be wondering, should I write X greater or equal to 925, or should I just write X greater than 925? It doesn't matter. Remember, the probability of X being equal to 925 is 0. So if you write the greater than or the greater than or equal sign, it is going to be the same probability. It is going to be the same value. Okay, so it doesn't matter. And again, we're going to do this with the calculator and with Google Sheets or Excel. Before we think about using those functions, let's make sure that we are able to visualize the area we're trying to. I'm going to erase what I have here above. This time, we're going to label X equal to 925, and we're going to highlight the area above this X value. It's really important to visualize the area before you try to use a function, especially if you're using the normal CDF function. For the calculator function, you're going to need the upper bound and lower bound. It is important to have a visual of the probability you're trying to find. When you have a visual, you're less likely to make mistakes when entering the values into your function, either on the calculator or on Google Sheets. If you're using the calculator, you're going to use normal CDF. Your lower bound is going to be 925, and your upper bound is going to be a really large positive value. Here we're going to use 1E99. That is your upper bound. So again, our lower bound is 925, our upper bound is 1E99. Then we're going to be asked to enter the mean and the standard deviation. On Google Sheets, we have to be careful. We're trying to find the area above a X value. Here, I'm going to be careful. I'm going to write two steps. First, we're going to use the function equalnorm.dist. Our X value is 925. Then we're going to type in the mean, then the standard deviation, and then true. Once we find this, if we type this into Google Sheets or Excel, we're going to have the area to the left of X equal to 925. We want the area to the right. So the second step is to say, we need to take 1 minus the value you get from this first step. I don't have the value here. I'm just going to go ahead and write that function in parentheses. Okay? So again, just think of this as having two steps. You type in your function, you get the value. That value represents the area to the left. And then you go 1 minus that area. That is how you find the area to the right of a X value. So go ahead and try this. The probability of X being greater than or equal to 925 is approximately 0.8092. So we're saying the probability that a person scores a 925 or better on their SATs, it's about, let me convert this into a percent, it's about 80.92%. Now, what about the probability that a person scores between 925 to 1,190 on their SATs? Again, let's go ahead and write this probability using probability notation. Here we're looking at the probability of X being between 925 and 1,190. We're going to first use a calculator. You can go ahead and use the curve above to visualize this area. Here we're finding the area between 925 and 1,190. I'm going to go a little bit faster here. I can visualize the area between 925 and 1,190 in my head. Again, if not, it's good to have a visual, so go ahead and drop the curve and highlight the area between these two values. If we're using a calculator, we're going to use normal CDF. The lower bound is going to be 925. The upper bound is going to be 1,190. Then we're going to be asked to enter the mean. And finally, we're going to be asked to enter the standard deviation. So this is the function that you're using on your calculator. Now on Google Sheets, we're going to be careful. We're going to have a few steps. We're going to have 3 steps. First, we're going to find the area below 925. Thus, we need to enter equalnorm.dist 925, 1,100, 200, true. This is going to give us the area to the left of 925. Then we're going to find the area to the left of 1,190. We're using the same function. We just need to change the X value. Here, the X value is 1,190. Once you have these two values, you're going to take the area to the left of 1,190 minus the area to the left of 925. There's different ways of writing that here. I'm just going to write this using the functions. Take the area below 1,190 and subtract the area below 920. Go ahead and try this from your end. If you round to 4 decimal places, you should be getting 0.4829. Now, this is what I call leveling up. Think about it. You started by learning how to sketch a normal distribution, by learning the features of a normal distribution. Then you learn that we're able to calculate probabilities by looking at the area under the curve, under a normal distribution. Then you learn how to use technology to calculate that area, to calculate those probabilities. And now you're at the point where you can look at real life scenarios. And so this is the exciting part. being able to apply mathematics to real life scenarios.